Welcome to Calc with KJ, video system problem number 2. Question 24 in section 3.4 gives you an equation of hx equals negative 5x squared plus 20x. This is your distance equation of the parabola. Question A asks you, the upward velocity of the book is the derivative of height with respect to time. Write an equation for the upward velocity. Now first, what you can do is you can do the power rule, which I did here, which makes you bring down your power 2. So it means 2 times negative 5x, and so there's technically a 1 for the power of x, you just do 1 times 20. And so your equation would be Vx equals negative 10x plus 20. Now I redrew the picture that it gives you in the book, like my little swimming drawing and then guy drawing the book. And so what I'm going to do real quickly, let me put the thing down for me to get my Sharpie out. Okay, so when you plug it into your calculator, you can also double check your derivative, as you can plug in your equation of your distance, and then you can do tab on your function bar, shift minus, which can give you the derivative. And one thing you can note is at 2 it passes the x-intercept, so we're going to put a point here, and then also at 20 it passes. So you're going to have a relatively straight line from there to there, and so that is going to be your velocity function, or your derivative of your graph. Question B asks you, how fast was the book going at time x equals 3? Was it going upward or downward? And then explain. Well, first you can just plug in 3 for your equation. So you plug in for your velocity equation. So you get 3 for x, so it would be negative 10 times 3 plus 20, which gives you negative 30 plus 20, which gives you an ultimate, when x is equals 3, you get negative 10. This also means the book is traveling downward. You go back to the graph, and you can kind of see I haven't completely drawn the line. When x equals 3, you kind of put in a shifting line here, so it equals about here. So it also shows when on the parabola is when the book is coming downward from its initial throwing point. C asks, at time x equals 3, was the book above or below where Check threw it, and how far? So what I found is when x equals 3, the book is above from where Check threw it. I did this by using my distance equation. And so I plugged in 3 for x, and I got negative 5 times 3 squared plus 20 times 3, which gives you negative 45 plus 60, which gives you at h of 3 equals 15. So we're going to go back to our graph. And so where h equals 3, it equals about 15 here. And also you can see that when he throws it, he's about, we're going to use when the book leaves his hand, we have that as y equals 0. And so for us to say that the book was past him would be a negative number. But since it's a positive number, it's at 15, which means it's about 15, and the meters, we're using meters, it is 15 meters above from when he threw it. Question D asked, at what time was the book at its highest point, and how do you know? Well, when velocity equals 0, it also equals a change in acceleration, which also means that the book is at the maximum height. So going to do our math over here, we have 0. We're going to plug in 0 for our velocity to find our x value. So we have 0 equals negative 10x plus 20. So we check 20 from both sides. You get negative 20 equals negative 10x. Divide both sides by negative 10. You get x equals 2. Now you can plug that back in to your equation for your height to find your maximum value. So you have h of 2 equals negative 5 times 2 to the second power plus 20 times 2, which gives you negative 20 plus 40, which gives you h of 2 equals 20. So your maximum value is going to be at 20 when at x equals 2, so 2 seconds. Also, on the calculator, plugging your random function, you can do the maximum function. Or you can do where you find your velocity, or x equals 2, you plug in a straight line to find the interception. So the highest point, the book is at 20 meters at 2 seconds.